Hello everyone. So today we are going to do Leetcode question edit distance. So in this first question which we are going to do today, we will be going ahead with three approaches: recursive and doing its memoization, and then after that bottom-up DP. Now comes the part that how we would be doing the recursive approach over this question. But before that, we need to understand about this edit distance question. So let me explain you this. So here comes the part. So now in this question, what we are doing is, here we are required to that we are given with two strings, word1 and word2. We are required to return the minimum number of operations required to convert word1 to word2. And how we can do this is, either we can insert a character, or we can delete a character, or we can replace a character. So this is the question given to us, and here this force is given and the rows, two words are given. So how we will be making this force to the rows? Now comes the part that for making the same, we can do this thing, that replace h by r. So h would be replaced by r, so it becomes rows. And now we need to do is, we just need to remove r, the third r which is here, right? And then it will become rows, and now we need to remove e. So basically we took three operations for doing the same. And same comes the part for intention and execution, that some removal is done, insertion is done, and replacement is done. So while doing all these three operations here, and then these operations are done in manners that we are at minimum able to get this particular word. Means with minimum operations we are able to get the other word. That's the thing which we are doing. So here the constraints are that a word length 1 and a word length 2. Basically both of them are not more than 500, and word 1 and word 2 have only English lowercase letters. So this was all about the question which is given here. Now let us move ahead for the explanation part. So for recursive approach, how we are required to write a recursive solution, and for that we first need to check in a question only, as we are required to convert one string to other string, and we can do by three options only as per the question mentioned, that we can do insertion, we can do deletion, and we can do replace. And if you could recall in the last video of LCS, what two operations we were able to do? We can either insert or we can delete. But in this edit distance question, only one operation is there that is being added, and that is what it makes it somehow a bit different from our LCS question. So here, insertion and deletion is same as the LCS, but only replacement, we need to take care of that. So tweak in the LCS question to make it edit distance question. That is what has been done. Now comes the part that how we can go ahead with recursive solution. So for that, first we need to check according to question only that what things are there. So for checking that is when we can insert or delete or replace, on which condition we are required to do. See, if the word is same, right? If I take example, cat and cut. So here is we see this T is same, right? So as both of them are same, so we will enter this case 1. So case 1 says that if S1 of m is equals to S2 of m, then no changes are required, thus we need to move ahead. So accordingly we will code for this particular case. Now case 2 comes that we need to insert, replace or delete at only that moment, then when both of the characters are not matching. That is the scenario, because what we are required to do, that we need to change one word to other word, and when we are required to do the same, then surely there is some non-matching scenario. So for that particular purpose only we need to do some operation. and that's the thing which we are doing here. So further sub cases which are being generated here is that either we can insert a character in S1, or we can delete a character from S1, or we can replace a character in S1 from a character in S2. So how we need to do this programmatically? See, as the S1 is having the character count as n, and the S2 is having the character count as m. So what we would be doing is, when we need to insert something, say if we take this example only, cat, and let us say take example of Q. So now for making T and E, both of them are unequal, right? So for making cat into cute, what we are required to do? We are required to insert something here, right? When T is here and this is here, if we choose this particular operation, that is insertion. So our T would be at this particular, means n pointer would be at this particular position only, and we would be adding E here. That's why n is basically here only, but we are moving ahead in m. So we will move here, means we will move at T. Now we will check that T and T both are same. So this case 1 would be considered, right? So then again we'll ignore both of them, but no operation is counted. Till now only one operation is being counted. Now we take as A and U. If we go ahead with insertion, right, then again we'll move this to this particular, not this one, but we'll move this to this particular, and we will be adding U here. That would be the scenario. So when we add U here, basically here U would be added, and this particular A which was there, that will remain at this particular point only. Or if we choose to delete, then in that scenario, what would be the case? That this A will be moved to here, that is we directly excluded this A, and this pointer at U will remain here only. So now this particular word is somehow like this, means one operation is again done, and this word becomes CTE, and the other word which is down there, it becomes CTE. That is the thing it will become, because this will be same, this cute only, and this CTE will become, because T just skipped the A. This is a scenario which we will be doing in delete. But if we don't do this particular, and if we do replacement of the words, then how this particular would be like? Then till now we have this TE and TE, right? Now A and U was the point. So if we replace A and U, then we will be skipping both of them, and then our new word would be something like this, and the other one would be also, because we skip both A and U. So here, that's why we are doing n-1 and m-1. And in deletion, how we are doing that? We are skipping the first one, that is this one, and that other word having the pointer at same position, and when we insert, then again we are adding some character just behind it. So that's why we are not skipping, and we are just staying at that particular character only at where we were staying previously. So that's how this will work in our program. Now comes the next part. This was about the cases which we are required to handle in our recurrence relation. Now comes the part that we are now knowing about the options, about the recurrence relation. Now comes the part for the base case. Because we would be traversing this whole length, if you can, now here I have explained you about the cases. So yeah, now it would be required to explain you that recursive tree which I just made. This is one of the examples that how things would be. But you can see that whenever we reach a particular blank, right, in that scenario, and even when one of them is blank and other one stays, so in that scenario, what is the operation which we can do? Either we can skip that, means delete it, means we can delete the other one. That simply means we can insert that into this. But here delete operation won't work, and replace operation, yeah, that will work here. because we would be skipping both of them. But the first one doesn't have anything. So how we can skip? So this all scenario picks up a base case here, that if n is less than 0 or m is less than 0, then we need to return +1 in that particular scenario at that moment only. So that's why here the base case simply becomes this one, that now we are not able to traverse our particular string, that is, it is now empty. So that's why at that moment only we will return +1. Why we are returning +1? Because when it becomes less than 0, that is now no index is there. So at that scenario, either we can insert or we can delete or we can replace. So that's why for that particular scenario we are giving 1 to that thing. So this is the thing which we will be doing there. So this was about recursive relation and base case and the options. Now comes the part that how we need to memorize it. So for memorization part, you can see that we are having two variable parts, that is n and m. So that simply reflects that we would be required with a two-dimensional data structure. And for that purpose only, when we require a two-dimensional data structure, so we are required to store our result, and for storing a result of our recursive calls in the same. So in that scenario only, we will be doing all the same. Because when we are going ahead with all the recursion part, then there would be a lot of sub cases which will be repeating again and again, and that's why we need to memorize a solution. Because when there were a lot of solution, means basically there were three choices which we were having, and each choice was n plus m raised to power not this one. We were having three choices and each choice was having n plus m times of occurrence. That was the thing. So that's why the recursive time complexity became something like this, and the space complexity remains n plus m. But now comes the part when it becomes a memoized solution, then in that scenario the time complexity becomes order of n into m because of this 2D ds which we would be taking, and the space complexity, that also becomes n into m just because of this 2D ds only. So that was the scenario how we reduce the time complexity of exponential time to a we can't say it linear, but it is in square only. Means from exponential to square time complexity, we have changed the solution. So this was about the same. Now let me explain you about the bottom-up DP. So for bottom-up DP, if we convert our memorization part into a tabular form, how it would look like. So here the thing would be that we need to be concerned about these three operations only, right? Insertion, deletion and replacement. So for bottom-up DP, we need to take care about our base case, our state and our transition. So our state here would be in two variable parts only, that is one for the word 1 and another for the word 2, and because we need to require doing operation according to insertion, deletion and replacement according to both of the words, right? So that's why what we would be doing is we will be having a two-dimensional data structure again here. So our state would be dp of ij, where I simply represent the pointer which is for the length of our word 1, and j simply represent the pointer for the word length of the word 2. And now comes the transition part. So here transition will take place according to three operations, that is insertion, deletion, replacement. And in that case also, when both of the words are equal, so in that case also there is the operation which we are required to do, but that operation would be counted as 0 only. So here we can add that, and it would be 0 plus 1 when both are same. Basically, I am adding up the transition which we are required to do. So when both are same, then in that case transition would be like this, that we are skipping both of the words because there is a match. But there would be zero addition into the operation, because what we are required to do is that we are required to have number of operations. Now comes the part for insertion, deletion, and replacement. Again, for the same case, the way we were having for the memoization recursion part. So we are required to add up 1, 1, 1 at each of these cases, because all of this will contribute to one operation. So in the insertion scenario, here we are having TP of I, right, and j minus 1. That is because of the case which I explained above, that we are inserting one character to word 1. That's why it will remain at that position, but we will be skipping our present character of word 2. That's why we are making j minus 1. And same for the deletion, and then same explanation for the replacement. So that's why we are doing this. Now for a question, what we are required is that a question requires the minimum number of operations required, right? So that's why we will directly do minimum of these. So that will complete our question. Means doing this operation and finding out minimum out of these. So to sum up everything, what we are required to do is, in this DP, our base case, that would be simply if n is less than 0 or m is less than 0, then in that scenario we will be returning +1. That means when we will be coding, then in that scenario I'll explain you that how it will be. And the state would be TP of ij. And why TP of ij? Because we are required to change word 1 and word 2 both. And then now comes the part of transition. So for transition, if our S1 of I is equals to S2 of j, then in that scenario we will be directly returning, or here because it is TP, then in that scenario we will be directly adding up now dp of ij equals to dp of I minus 1 and j minus 1. Else means when both of the characters are not equal, so in that scenario we need to have minimum out of all these, and we can do one outside only because we are finding out the common out of them. So 1 plus minimum of, and this will be directly added up to this TP of I and j. This is that scenario when we are basically deleting. This is the scenario when we are inserting, and this is the scenario when we are replacing. So this is the thing which we will be doing. Means our base case is now ready in state. This is state and transition. And in the tabular, for our base case, that we will be replacing by just one thing, that is we would be filling out our DP array, and that will replace our base case most probably. But that we need to check while doing our code. So now let me show you how we are required to do the code. So here first comes the part for recursion. So for recursion, first we are required to make a recurrence recursive function, and this is how it is. Means we are going ahead by passing the word 1 and then length of the word 1 minus 1, and then word 2 and length of the word 2 minus 1. Now here we are ready with our parameters. Now comes the part, this is the base case which we are taking, that if our length is basically less than 0, then we would be returning n plus 1. If our length is if our length of the word 2, if it is less than 0, then we will be returning n plus 1. That is, we would be directly returning the opposite one, that whatsoever length is remaining, and this is that scenario. See, if we take, okay, if we take cat and cute, that example only. So if by let me add arbitrary character. If all these are now done, right? So if at the end say here we have this D also, and all these had been cut in some scenario. So now here we are left, right? Means there is one empty character, but this one is still left to be filled up, right? So that's why in this scenario, what we will be considering is the length of this plus 1. That is, we can insert this particular character into this one, and that will also make our particular word matching, or you can say conversion of one word to another word successful. So that's why what we are doing is we are directly checking that if first word becomes less than 0, then we will be returning the whole length plus 1 of the second word, or if the second word becomes empty, then we will be returning the length of the first word which is left and plus 1. So that is how we are taking the base case here. Now next thing which comes up is that if both of them are equal, that is the case 1, then we are directly moving ahead. That is we are moving towards the 0th position because we are starting from the length. Else we are required to consider those 3 cases: insertion, deletion and replacement, and at the end we need to return 1 plus minimum out of all these 3 operations, and this is what we would be doing in this DFS, and thus at the end we will be getting answer into this particular DFS, and that would be returned. So this is how we are doing our recursive solution. Now comes the part for the memorization. So for memorization, we need to introduce a 2D vector, a 2D array into the same for storing this particular. So now let me show you the solution for the same, how we would be doing for the same. So for that scenario, here again the base case remains the same, and we are first because we have not declared this particular privately or publicly. Basically, we hadn't made it a global variable, and we have directly make it here only. So that's why I'm passing this as one of the parameter. Else, if I would have made it a global variable, then I won't have passed it here. And here I'm directly taking a 2D vector in which I am passing the word 1 length and the word 2 length, and initializing the whole 2D vector with -1, and then I'm passing it to this particular function, and then here the same base case, and then this is for that sub, means returning that sub case if my DP is not filled with -1, but then it would be surely filled with some other number. That's why I'm doing this. And then comes the part, the first case, that if both of the word are equal, then we don't do anything, and that's why we are directly returning this by entering that particular case into this. And then comes the else part. So for that else part, we are just first calculating all our things, and then at the end, at the returning portion, we are doing this. We have just inserted our vector here. So that's the thing which we are doing here. So this overall thing, elimination of all the sub cases which we were earlier getting, basically those sub cases which are basically duplicate. So this makes our solution as m into n, because now there is no exponential thing. Means whatever sub cases would have been duplicate, they are now stored somewhere, and they are being fetched at this step. Now comes the next part, and that next part is about bottom of DP. So for bottom of DP, what we are required to do is, we first, the base case which I was saying, that base case would be replaced by basically this particular scenario, because now we need to handle everything with the help of the table only. So that's why we are doing all this. So first comes the part that what are the length of n and m, and for that scenario only we are doing all this. First thing is that we are initializing it. So for initialization part, although we hadn't taken here anything for initialization, we are just declaring with the length. Now the length is n plus 1 and m plus 1, n plus 1 number of rows and m plus 1 number of columns. That is the length here. Why we are taking that plus 1? So that we have that extra row and extra column where we will be putting our base case scenario. So this is for our base case scenario only, where what we are doing is that for each row which is there, we are directly filling up with I and then we are filling with j. That's what we are doing. Means basically if we are having this number of words A, B, C, one row is extra here, and then A, B, C, so one row is extra here for this one and one column is extra for this one. So as we are filling from the length, so it would be filled like this. That's the thing which I am saying. That's how we are filling this. This is what we are doing here. Now comes the part that how we need to calculate in this particular. So we have taken a nested loop. One would be running for the number of rows and one would be running for number of columns. So first thing we'll check that is word 1, I minus 1 and j minus 1. That is, we are starting from 1, right? So that means we are starting from here. Now what we would be checking is that we will check that I minus 1 and j minus 1, that is at this particular point. So here it is already empty, right? Here it is empty and both of them are equal, right? So this one would be directly skipped and this value which was 0 here. So now at this particular point, that is 1, 1, it would be having 0 value. So that is how it will be starting. Now comes the part, then we come to this B and C. Let me replace the character, else I won't be able to explain. Now comes the part that we now had it towards I was equals to 1 only and j equals to 2. So in this scenario, now j is equals to 2, now it comes here and I is still 1, then A and B, both of them are unequal, right? So it will check out of these three scenarios which is there. Okay, my cursor is not visible. Out of these three scenarios, we will be saying that which one is the smaller operation which can be done. So we will check that I minus 1 and j, right? So we will be checking that what is being filled at I minus 1 j position. So I is basically at A, I minus 1 is 0 and j simply reflects this particular position. So at this position we are having 1, right? So here it will be filling up of 1. So now comes the part of this particular I and j minus 1. So I is basically 1. So it is here and it says j minus 1. So j is basically 2. So it comes again at this particular position. So again it is 1. And this I minus 1, j minus 1 comes out to be 0 because it will head over to this particular 0th position itself again. So minimum out of them is the 0. So that's why at this particular position, when we add 1, because we did one operation, so at this particular point, when I equals to 1, this equals to 2, then we are having this one as an answer. Now comes the next part, when j equals to 3. Now we are at this particular point. So when we are at this particular point, so what we are required to do is, we'll now again both of them are not equal, right? So when both of them are not equal, so at that particular scenario, what we will be doing is, because C and A both are not equal. So again we will be checking, and when we checked both of them, then what we got, that we need to check. So here we can see I minus 1, j minus 1. I is equals to 1, j equals to 3. I minus 1, j minus 1. So if we insert, then is that if we delete basically, first I have written about delete, then it comes to this particular point, I minus 1 and j equals to 3. So it remains at the same. So it is at this particular scenario only, means it is at this block only. So here we come with 3. Now j minus 1, that is it reaches here, but it needs to be at I only. So it reaches at this particular point, that is 1. So this comes out to be 1. Then I minus 1, j minus 1. So it comes out to be 0. So then again it comes out to be 0. So that's why minimum out of them we got 0, and that's why this undo is not working. So that's why again at this particular point we are having 1. So like this only we will be able to fill up the hole, and at the end, because there is just one replacement, that is of the C, so here we will be getting 1 as our answer. So that's why we return dp of nm, because whatever answer we will be getting at the last mode cell only, and that's why we are able to return dp of n into nm. That is the last state which we are required to return. Here also the time complexity would be order of n into m, because you can clearly see that we are using a nested loop, and now comes part of space complexity, that is also n into m, because you can see that we are using this particular table, and this table is being made by this 2D vector whose length is n and m. We can discard the plus 1 because it's negligible in context to n and m. So that's why our space complexity is n into m. So this was all for this particular question. If you have any doubt, you can comment that down. So thank you.